take 3 on this video. Jumping in, about graphs. I know this first slide well now. So, we use a lot of graphs and data tables. You have to be able to read them. You have to be able to make them. We're mainly going to use bar graphs and line graphs, but the other ones being histograms, box and whisker, pie charts, scatter plots, all can show up just less frequently. So let's jump in. First, we're going to talk about bar graphs. Bar graphs, I see students get tempted to use them more often than they should. They should really only be used when we have things in categorical groups. So things where there's not really a nice continuity between different groups. Like if you look in the top right, they asked people what was the nicest fruit, plotted the results. They just counted up how many people said apple, how many people said orange. But there's no continuity between apples and oranges. You shouldn't draw a line between apples and oranges. They are different things. They are different categories. So whenever you have things split into different categories, you should be using a bar graph. Generally, it's used when we have to count things and when you can't really have partial amounts of things. Like when they asked all those people what is the nicest fruit, you couldn't have a part of a person. You either had the person voting for that group or you didn't. There was no partially in that group. So, countable, categorical is generally what gets plotted on a bar graph. Histograms are very related to bar graphs. They obviously still have bars, but they're showing a distribution or a frequency of various outcomes. And the outcomes, differing from a bar graph, the outcomes can be continuous. So if we look at the top right with the test results histogram, you could draw a line between 30 and 35 and it would make sense. There is a continuity between those two data points. The category of 20 to 30 is not fundamentally different than the category of 30 to 40, but we are still putting them into categories and counting the number of students that fall into those categories. The students, which is our y-axis, they're either in a certain category or they are not. There's no partial, there's no fraction, there's no decimal. Even if you score a 25.5, you still end up in the same category as 25. So they may have variables that are continuous, that are not counting discrete or categories, that can have a whole spectrum, that can have the whole decimal range. But we're specifically putting them into specific categories. So like with heights of the cherry tree, height in feet is a continuous variable. But if we are just plotting how many cherry trees are between 60 and 65 feet tall, how many between 65 and 70, etc., that makes it need a bar graph or a histogram. Key difference, bars touch. That's about it between this and a bar graph. Next, box and whisker plots. These do not show up often. I had taken them out of curriculum, but then they showed up on a single question, so they're back. These are also showing distribution of data points, so like how spread out is your data, showing things like your standard deviation. And they have what is called a 5-number summary, so they can give you a lot of information about a set of data just by quickly glancing at the graph. The 5 numbers, though, include the max value that was measured, the minimum value that was measured, the lower quartile, which I'll talk about in a second, the median, and the upper quartile. And they're nice and useful because we can use them to compare data sets just kind of visually at a glance. So if we look at like store A and store B on the right, if we were to ask which one do you think sees more customers on average in a given day, we can just look and say, oh, store A, because the whole box is basically shifted that way, even though they had a lower minimum, on average they have way more. So how do you make a box and whisker plot? It uses that 5-number summary, so you need to know all 5. Easiest ones, minimum and maximum, self-explanatory, not going to get into that. The median is the middle number. If you have that list of numbers written out, you like cross one out from the left, one out from the right, and keep working your way towards the middle. That's how I did it in elementary school. I don't know if there's a faster way to do it. If it's an even set of numbers and you don't have an exact middle, you just take the average between the two centermost numbers, and that calculates your median. And then hopefully those ones you knew. These ones are probably something you haven't talked about in a while. Your lower quartile is the median of the numbers, all of the numbers to the left of your median. So you put in your median, and then you have a new set of data to the left, and you find the median of that data. Same thing with the upper quartile, except it's the median of the numbers to the right of the median. So it's kind of like, this is what your average is. If you are above average, this is what you're likely to be. If you're below average, this is what you're likely to be. A bit weird, but it does show, again, that useful whole box structure that lets you see kind of how spread out your data is. The closer everything is to the median, the closer all your data is, the more accurate it tends to be. These ones really don't show up too much. I would mostly focus on how to read them and not really how to write them. And really just being able to get the qualitative which data is more spread out than the other is probably enough. Next graph is scatter plots. These, we really don't get asked to graph them very often because they have generally too many data points, and benefit heavily from computer analysis, but they are showing relationships between variables or correlation to see usually if one exists. So the data is usually spread out. It's a ton of different data points, and you're plotting a continuous variable on the x-axis, and then whatever you're measuring on the y-axis. But we do not connect any of these dots together. We can draw what's called a line of best fit through, which is just kind of like a straight line that hits as many of the points as possible. It's trying to show what the trend that might be there. They can technically be almost any shape or any type of function that you want, but we will only have to deal with linear lines of best fit, and it's generally just, can you pick out the trend? So like the trend in the upper right one is that as elevation increases, annual temperature decreases. On the bottom one, it's as grip strength increases, arm strength increases. So just being able to get the trend is usually enough. You probably aren't going to be asked to graph one. The line of best fit, just to talk a little more, you're trying to draw a straight line through the average or middle of the points. You're just trying to get like the same amount above and below. Don't extend it out completely beyond or draw any arrows or anything. In my time, I haven't seen or heard of one where they ask you to draw a line of best fit, but they could. Okay. Line graphs are the second of the most common graphs that you'll need to do and use. They are similar to scatter plots. They're showing relationships between continuous variables. But we're usually, in this case, not trying to discover a correlation or anything. We're trying to track some change over time is the most common. It could also be a change over temperature or a change over pH, for example. But usually the x-axis is time, or honestly your big ones are time and temperature. And then your y-axis is anything that you are measuring. We use a line graph if we are trying to kind of see individual changes over a period of time or over a range of temperatures, rather than trying to just say there's a relationship. We're kind of trying to see the whole trend line. So like people in the store, we couldn't do a scatter plot here because there wouldn't be a correlation, because the trend line would change kind of halfway through. And so we use a line graph to be able to capture that change so that we can say, oh, The number of people in the store tends to increase until about 1 p.m. After that, it decreases until close. If you had done a scatter plot, you would have been forced to basically say, as it gets later in the day, the people in the store either increases or decreases. So it's a little bit more limited. Last but not least, but kind of least, pie charts. I don't see these very often. You're comparing categorical groups proportionally to each other with percentages, just showing you relative ratios of things. They will not ask you to make a pie chart, but you do need to be able to read them. Thankfully, they're pretty self-explanatory. Okay. Let's talk about how to make the graph itself. Every AP Bio FRQ section will have one graphing question where you have to make a graph, which should be free points. So if you remember to do these things. So first thing you need, title. I've seen differing opinions on if it's required or even wanted. Just put a title in, be safe, have it describe what's going on in the graph. In this case, it's just relation between fertilizer and plant growth. Great. Then you need a labeled axis that includes units. So we have fertilizer in grams and plant growth in centimeters. Generally, they will give you a data table, and the headings of that data table will be the labels for your graph. So the data table they would have given you with this graph would have had fertilizer grams in one column, plant growth in the other. Just copy the headings from the data table, and you cannot go wrong. Your X and Y axis needs to be properly scaled, so it needs to use a good portion of the graph, essentially. Meaning, like this one went from in increments. The first one is 20, but then after that it's just increments of 12, which you are allowed to do if it's right at the beginning. But you just need to have a consistent scaling, and it needs to use a good amount of the graph paper. It shouldn't be all squished into a corner. And then if it is a scatter plot, you should draw a line of best fit. And that is it for graphing. Next and last video will be on the standard error of the mean, which is probably the newest topic in all of this to y'all. So good luck. Hope you're enjoying. That's all. Bye.